Hello everyone, my name is Aiden and welcome to the first week of Rockstars. Today I'll be doing an overview of this event. Rockstars is about rocks and minerals, specifically identifying various specimens and answering questions about them. Before we start, it's important to clear up a common misconception. Rocks and minerals are not the same. A mineral is defined as a naturally occurring substance that has a specific chemical composition and a well-organized atomic structure. It cannot be derived from organic matter. In contrast, a rock is a composite material with a variable chemical composition comprised of different minerals assembled through various natural processes. To summarize, while all rocks contain minerals, minerals cannot be classified as rocks. Next, we will start with the various methods to identify rocks and minerals. There are many techniques for identifying minerals, primarily based on their distinguishing properties. These properties can be categorized into useful and less useful characteristics. Key properties of minerals include hardness, cleavage, luster, streak, color, specific gravity, crystal structure, fracture, chemical formula, and several niche properties such as magnetism, reaction to acids, diaphanity, electrical properties, fluorescence, and tenacity. It is crucial to note that while many of these properties can be reliable, color is not a dependable indicator due to the presence of impurities or dust that can alter a mineral's appearance. Hardness. The hardness of a mineral is gauged using the Mohs hardness scale, which ranges from 1 representing the softest minerals to 10 representing the hardest. Some minerals, known as indicator minerals, possess a whole number hardness values. Diamond, for example, is hardest with a hardness of 10, while talc, known for its softness, has a hardness of just 1. Cleavage and fracture relate to how a mineral fragments when broken. For example, quartz exhibit a conchoidal fracture, revealing smooth curved surfaces, while muscovite is known for its perfect cleavage in one direction, allowing to split into thin sheets. Luster describes the way a mineral reflects light. Diamond, with its brilliant adamantine luster, shines exceptionally bright, while kaolinite exhibits a dull luster, absorbing much of the light that hits it. The streak test is another important tool in mineral identification. Unlike color, which can vary due to surface contaminants, streak color remains consistent. For example, hematite, despite its many colors, shapes, and sizes, consistently produces a reddish-brown streak. Specific gravity measures a mineral's density, providing insight into its composition. For example, quartz has a specific gravity that ranges from 2.59 to 2.63, influenced by the impurities present. Crystal structures examines the atomic arrangement within minerals. Halite, for example, has a cubic atomic arrangement, giving it an isometric crystal habit. Understanding chemical formulas is also essential, as they are common in tests. Another example, quartz can be represented by the formula SiO2. Other important topics that will come up on tests include mineral crystallization and the rock cycle. Mineral crystallization is graphed using the Bound's reaction series. This series describes how minerals crystallize from felsic or mafic, also known as the continuous and discontinuous branches, lavas to form a variety of rocks and minerals. The rock cycle is a diagram that is composed of three different rock types: sedimentary, igneous, and metamorphic rocks. Each type of rock are interchangeable. This means that each rock can go through chemical and physical processes to alter their composition, hardness, and various other properties. Identifying rocks is a lot more challenging than identifying minerals. It requires more comprehension of their compositions and properties. Remembering all the rocks and their respective characteristics is key to successful identification. This concludes our introduction to the basic of identifying rocks and minerals. Thank you for watching.